Okay, so I'm just going to today run through building our ultra light end-fed antenna, which is this one. You're going to hear some noise in the background, which is my my cabin heater, because it is actually still winter here in England. It's about -3 outside, so something good to do is to get in the shack and actually build a kit for you guys. So just talk you through the kit. You get the PCB, there's a BMC connector, toroid, whichever one you've picked, some enamelled copper wire, a couple of cable ties, capacitor, and the kit for mounting the antenna wire itself. In a later video we'll go through setting up this antenna in the wild with some of our ultralight antenna wire, but we'll do that outside. This is just our first ever video indoors. Yeah, so we'll crack on and I'll show you how to build this. It's probably about the easiest kit we have to build, and it does work, which is quite nice as well. It's not one that is a problem. It is actually very small, which is why everything is you know, kind of, it's not fiddly, it's just what it is to build. But very simple, very easy kit. So the first thing I'm going to do is I will take the wire that we've supplied apart. Okay, and what I'm going to do here is I'm actually going to, I don't know if you can clearly see this, but I'm just pulling that through my finger and thumb just to make sure that the wire is pulled out reasonably well. This kit, you're going to get somewhere between, I guess, 4 foot to 6 foot to do the windings, which is way too much, by the way, absolutely way too much. But we'll go through it anyway. What I normally do is I do actually trim quite a bit of this wire off, which I'll do. I'm going to actually take the wire roughly in half, which should be fine and should give us a couple of goes at doing the antenna if we needed to. Okay, so I'm just going to cut that in half. Now, the reason we supply more is due to the windings that some people like to do. Some guys and girls like to do a auto transformer. Others like to do 49:1, and some do all different terms anyway. It doesn't really matter. I'll let you do some research on that. I tend to build most of the antennas that we sell as 49:1, some as 56:1, and on special request I will build them slightly differently for people. So first thing is, remember that all we're really doing is winding the toroid, which is going to go, winding the toroid, which will be positioned on the board here, with a bipolar winding there, and the main connection to there, and the connection to the antenna at the back. So all we're going to do is just wind this up. I'm going to do 49:1. We'll go through the counts, which is the biggest thing that I get asked questions about, is how do we actually count that, and then we'll go through a quick assembly. The longest thing, or the thing that's going to take the longest time, is doing this winding. So what I'm going to do is I'm just going to take an amount of wire, which, let me just take this off a little bit, which is about 15 centimeters folded over. I'm going to pinch that end and then do some twists. Now the twists you can do like that. If you see me doing that, that's just giving you some twists there. You could clamp it into a vise and use a drill just to spin it up. That's fine, but for this kind of antenna it's not really needed. Or the other way of doing it, if I get a little cheapo screwdriver here, is you can poke a screwdriver through and just turn it that way. Okay, the only thing you want to do is to create the bipolar connections. Hopefully this will focus okay. Come on, focus. I don't know, let me just double check that you can see that. Which are these twists? Bear with me. It's just that twisting along there, and that's probably the hardest part of the build is done. Now, the next part, if you can see, you've got two ends there that are now split. That one will be in this hole, and when you wind around, the bifolar will be in this hole here. Okay, so what I'm going to do is I'm just going to take the toroid, just squish that a little bit there, and I'm going to start the winding process by placing that toroid there, pulling that backwards, okay, and then winding twice around. That counts, when we pushed it backwards, sorry, each turn through the middle counts as one. So that's the first turn already done. Try to get the camera to focus. That's the first turning that's done, that's one. We can then go through the middle of the core, pull it snugly. I find giving it a wiggle is quite good, and that's two. So what you've now got is your first two windings. Okay, so let me just pull that out a little bit. I don't know if you can see that. So on the outside you'll see two, on the middle you see two, and then what I'm going to do is I'm just going to complete the windings as follows. So that's the third winding there, it's actually quite difficult to do backwards on the camera. So that's the third winding, the fourth winding, so once that goes through, that's number 4. Okay, hopefully you can see that okay. The 5th winding, winding number 6 is now going to go through. We'll count at 7 in a second. Number 6, that's going through, and number 7. Okay, is going through. So that's 7 turns. Really, really easy to count. It's what's on the inside. 1, 2, 3, 4, 5, 6, 7. We're then going to do an 8th turn across to the other side. So I'm just going to pull that to the other side, like so. Oops. Try not to kink the wire. Okay, so that counts as your 8th turn across. Keep some tension on the wire, and then we're going to go 9, 10, 11, 12, 13, 14. So we're going to add another 6 turns. Do, 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 do. One, 2, just try to keep them evenly spaced. 3. Okay, again just some slight tension to keep that wire nice. 4. So 5. And 6, and you'll see the 6th turn, which is number 14. I'll double check this in a second, by the way. Is going to form the actual antenna connection itself. So let me just tidy this up a fraction. Okay. actually sounds like my heater is now slowing down, which means it's a little bit warmer. So let me just put that there so you can see it in relation to the PCB. Okay, so I'll just bring that up to the camera a little bit. So kind of what you're looking for is to end up where the wires roughly match where the connections need to be. Okay, the most important one is the one on the back there, which is where the both bipolar connection goes, as well as the normal one. Now there's a trick, very simple trick, which is now just to snip these wires a touch. Snippers, scissors. The wire's really thin with this kit, it's only 1/2 mil, so it doesn't need a lot of effort to snip. And what I'm now going to do is I'm going to position the toroid as if it's there permanently. And the way that I'm going to do that is take the two points there, which is the bipolar and the normal one, and push them through the bipolar and the normal connection on the PCB, like so. And on the other side, I'm just going to twist that fraction. Sorry, twisting it a fraction, not on camera, is not good, so just push that wire, push that wire, see, a little bit fiddly, but it's fine, through there. So that's the position. Sorry about that. And here's a man who's made 100. Yeah. Right, so it could be just a little bit fiddly. I'm trying to do this without necessarily looking at it well, which is causing me a problem. Okay, and those wires are in place, and then you can put them tight. The reason being is you can just make sure that you know how much of the enamel you need to take off. Now, at this point, there's loads of ways of taking the enamel off. You can use a sharp knife, such as this one. You can use your soldering iron and burn it off before seating it, or you can actually just solder it directly onto the PCB. I tend to scrape a little bit of the enamel first and then solder, just tin those connections. But the main thing there is if I just lift that off, we can see roughly how much we need to take off. So the PCB level is going to be somewhere around there. Okay, somewhere around there. So what I'll now do is I will leave the camera rolling whilst I just scrape some of the enamel off, and then I'm just going to tin it using my soldering iron. I'll just move these other components out of the way. Reading glasses probably would have been good for this. Okay, so that's literally all I'm going to do. Just have a quick scrape around to remove some of the insulation that's on that wire. I tend to find doing this is quite good because we end up in a position where it's then very, very easy to tin. Put that one back in place. And then using your favourite, let me just try to get that lamp on there a little bit better whilst we're doing this. You can then use your favourite solder and soldering iron, and then you just burn off any excess, any excess enamel. Now my soldering iron, I don't know if it's that accurate actually, but it's set at 420 degrees. What you do have with copper being a conductor, even though the enamelled copper is will come off at just over 100 degrees, you tend to have to set the soldering on quite a bit higher for that to work. Okay, so let me just show you there. That has, let me just put my finger there, that has tinned that part. I will just go around to the other parts and tin those off. On the early boards that I designed for the ultra lightweight, I didn't really take into account the solder on the tinning for the bifolar, so I still got about 80 of the earlier boards, which work perfectly. If I make them, I use them, but it just means I have to build it a little bit. Can be a little bit more tricky to build, so they're not shipped as kits anymore. They come as a complete build, and they're great little antennas. These, they'll, particularly with this core, the 82 core, you'll run 20 watts fine. I've had that sideband, by the way, I've had clients running a little bit more, but I would never recommend it. And then that means that you're kind of going out in the field with something that's tiny. I mean, it really is tiny, but you can build it yourself. We've also got cases, if you've got a 3D printer, that you can use. They've all been modelled up for you to download and play with, or you can just use the board. So if you can see that again, we've got the bifolar done, the centre pin done, and what will become the antenna connector done. Okay, so they're done. So that's that. I'm just now going to pop that back through the board. Let's give that a little bit of a trim, because we've got a little bit of a bump there that will impede it from going through. So I thought I'd say that. We're radio amateurs, right? So we use impedance. Let me just push those through there. And now we'll push that one through, and that is roughly where we're going to solder. Now, your choice, but what I tend to do is to now mount the toroid onto the PCB before I solder. That way it ain't going to go anywhere, right? And you can check the alignment, and everything is normally then good. If you solder it, it might just be the case that you don't center it correctly. It's not going to affect the antenna at all when it's built. Just tidy that up a little bit. Okay, you can just see that done. Okay, so that's tidy. We'll put a second cable tie through this hole here, second cable tie. So it's just through the board, up the other side. Let's see if we can get some light on that. Through the centre, give it a wiggle. A bit more of a wiggle required. Okay, that one's snug. That one's snug. And then what you've got is something that's perfectly workable. Okay, I will just trim this now. Okay, remember this is not soldered at this point in time, so that's trimmed. When I build the things, what I tend to do now is take the capacitor. That's your 1 kilovolt. Oh, put it around the right way. That's your 100 picofarad 1 kilovolt capacitor. Again, trim the legs. And I'm going to push the capacitor through the cap holes. Again, put it up the right way. It's going to say cap on the PCB. So it says cap just there. I'll just push that through like so. So, and I just bend the legs out slightly or completely, similar to what I've just done now. So we can now see on the bottom of the PCB we've got a capacitor and we've got our bipolar twisted pair. the non-bipolar, the antenna part, that goes to the center here. The bipolar, there goes to ground. We've got our capacitor in place. We've got our antenna end in place. We're then going to just solder those up, and we'll put the rest of it on last. So hopefully I can get this focusing. Let me just clear the desk a little bit and see if we can zoom in. Okay, hopefully we can see that and it's going to focus okay. Let me just see if we can get that to focus. Sorry, this is a phone, it's not anything else. And what I'm just going to do is support it with my finger, and we're just going to solder those pads. Okay, so that's the first pad. I'm right-handed, so we're going to go around. Okay, that's the capacitor pad. Probably the antenna pad. I'll turn it upside down. The next, oh, it's bipolar, definitely. The bipolar pad. And also, the last capacitor pad. So they're all soldered. If we turn the board over, probably a bit too much solder actually from me. You can see the solders run through. If I try to get that to focus, the solder is run through to the other side. Okay, a little bit too much now. Let me just get that in the light a little bit more. So the solder has run through, but that's there now. That's absolutely, that's kind of good enough. Okay, so the very last two things to do, we have our B and C connector. Now these work really easily. You just push them on. Okay, so you can see there's a set of pins that correspond to holes on the board. So again, I'll just push those through the holes. Again, reading glasses for me are probably a much smarter idea. And what you then have is you have the two pins to complete the circuit to the B and C, plus these support pins. Now, again, depending on what core you bought, this is the 82. Oh, let me get that on the screen. Depending on what core you've bought, you'll see that that sits parallel, roughly, very roughly, to there. So when we come to solder this, again being right-handed, what I can now do is put weight like that, and that is now in place, and all we've got to do now is solder up those connections. So I do the ones that actually support the B and C first, so just going to put a little bit of weight there just to make sure that's engaged properly. So let me just do that. These don't form any of the electrical connections, they just stop the B and C from falling off. It's kind of like a strain release. And then we're just going to do some soldering there. That's one pad, and the second pad, second solder pad. And I'm going to check that I haven't, that we haven't soldered across those two pins, which can happen. If you've done that, then you need to take the solder off and do it again. And if you're not going to be able to see this easily, I would just check that. Yeah, let's tidy that up a fraction. Sorry guys, let's just tidy that one up. That one needs just a fraction bit more solder on it. I just want to make sure that solder's run through correctly. Yeah, I think it has. Yeah, I can see that now. So we've got solder at the other end. Okay, so I now know that all of these are done and they're all connected. Now, quick bit of tidying up. anybody's got a 3D printer, you've got these. I've got loads. I've had loads of 3D printers over the years. So what I do is just trim off the solder pads. I tend to place my hand over top of the waste because otherwise it flies around the shack. Okay, so you can see I'm just cutting those bits off. We just do that. I think you can see that okay. And then just for a little bit of tidiness, I just very quickly touch each one with a soldering iron, reflow the connectors, just so it looks tidy. Not any other reason whatsoever, just for tidiness. And then the very last thing you need to do with this kit is the nut and bolt. Now it is an Allen key, so you need a 2mm Allen key. We used to supply them with screws, but it wasn't quite flush, so we can just spin on that nut. We're not going to tighten it today, but that makes the electrical contact on the PCB. We then put on the solder tab, which will be soldered to the antenna wire. Again, let me see if you can see me doing that. Okay, so that's now on. And that is your radio stuff, ultra lightweight end-fed half wave transformer complete, including the noise from my diesel heater. So my apologies for that, but as we say in the UK, it's bloody cold today, so it had to be on. So very easy kit to build, works really well. Like I said, with this particular core, you're going to get 20 watt sidebands. You'll get away with 10 watts with CW, 5 watts with data. The thing with any of these antennas is you kind of need to think about how you're driving them, because if you were key down 10 watts on CW and you didn't do anything else, literally key down, this will heat up. The efficiency on these cores is on the website. They're pretty good. Again, we do different cores in different sizes. They've all got slightly different traits, efficiencies. They have different sort of winding capabilities. They that are fit for different things. But this thing's actually tiny. Just trying to think of something that's comparable. Here you go. Let me zoom out on the camera and I'll show you how small they are. If anyone's got one of these, that's how small that antenna is. So these guys are really a nice kind of combo. I never box mine. It helps keep that cool. If you're worried about waterproofing, sticking in a box, a plastic bag, or steal your partner's clear nail varnish and paint over the connections. Yeah, so that's the kit. It's a very easy thing to build. You're only going to need a soldering iron, solder, and some clippers to build it. Nothing special. You can test it if using just a 2500 ohm resistor if you want to, or chuck it up in the air with an appropriate length of wire, and that will get you on air very, very easily. Okay, thank you very much.